everyone. In this lecture, we're going to be talking about exponential regression and complex regression in general. Now, I have with me here an Excel spreadsheet that contains the data for the stock price of MasterCard over the last 13 years or so. Now, this is not like a plug for MasterCard or anything like that. It just so happens that the graph that I'm about to display is very convenient for the purposes of this lecture. Now, let's graph MasterCard's stock price over the last 13 years, and let's see what we get. Now, that's what the corresponding scatter plot looks like, and it's not much of a scatter plot because there's specifically one data point for every single date out there. And let's try to model the relationship between the time and the stock price using a linear model. Now, as you can see, there are some problems with this, particularly this area right here and this area right here. On the left side, it looks like around 2007, 2006, the linear regression model was essentially, the outputs of the linear regression model were negative. And you can't have a negative stock price. And then at this point in time, 2018, 2019, we can see that the linear regression model greatly underestimates the value of the stock price. So the linear regression model is not that good. So can we use any other function to try to model this the relationship between time and MasterCard's stock price? And the answer is yes. We can try to model, for example, with exponential regression. And as you can see here, we have this, it's kind of hard to see, we have this curve. Here, let's see if we can get rid of the linear regression model. There we go. So as you can see, we have this dotted line, dotted curve, I should say, that represents the exponential regression model between the date and the stock price. That looks a lot better. And it turns out that exponential regression is typically one of the best regression models that you can use for stock prices, simply because stock price grows exponentially. Now, how do we develop the formula for this exponential regression model? How do we get there? What is so special about getting this model? Well, there is a slick trick that we can do. What we're going to do is we're going to try to, and I'm going to totally make up a word here, linearize our data with some function. So what I'm going to do is I'm going to take all the values of every single stock price, and I'm going to input them into a log 10 function. Now, most of you are going to be like, that's a really bizarre thing to do, but work with me here. I'm going to talk about what I just did there in a second. And now I have all of these values. So these values represent MasterCard's stock price plugged into the log function. Now, if I were to graph this graph, the relationship between the date and the log values of the stock prices, this is the model that I get now. Interesting. Now, it's hard to tell from this, but it looks like a linear model would do really well with this data, and it does. As you can see, linear regression can greatly predict the log values of the prices. Not necessarily the actual prices, but the log values of the prices. And so we could try to figure out what this linear model is, and we can use our calculator to do that. However, there's literally over 3,200 data entries, and so for data points. And so for that reason, I'm actually just going to have Excel do it for us. There's a little thing right here that says display equation on the chart, and that is our equation. Y equals 0.0005x plus 0.8587. Now, I'm actually going to pull up a blank sheet of paper for us, and we're going to do some math here. 0.0005x, 0.8587. So we got y equals 0.0005x plus 0.8587. Now, what does y represent in this context? Well, y represents the log values, the log, and specifically log base 10, of our stock price. I'll just put SP here. So if we wanted to predict the stock price, what we can do is we can find the inverse of this function, which happens to be 10 raised to the power of, on both sides. So our stock price can be represented as 10 to the 0.0005x plus 0.8587. 0.87. Now that looks kind of fancy. How did I go from here to here? Well, that part I'm not going to explain so much because, again, there's technically exponential regression on here that'll do all the math for you. But the idea is that, oh, there we go. Okay, so just checking something real quick. The idea is that this is just inverse functions. We're just doing some inverse functions. And if you're unfamiliar with inverse functions and what I'm doing here, you can take a look at some of my algebra videos. So we have a model to predict the stock price given our x value, and this function right here is technically exponential. I can actually write this as, and I need to make sure this is correct on my calculator, 7.22 times 1.00115 to the x power. So that would be my exponential regression model written in a different way. And so let's talk about what we did here so far. What we did is we took our stock prices and applied a function to them to make it linear. Then we found that linear regression model and then we did the inverse function applied to that linear model to get an exponential regression model. Now that sounds a little bit complicated, and I understand it is, and complex regression is technically kind of difficult to wrap your mind around, but that's actually how they do every single complex regression model, is you try to find some transformation to your data to make it linear, then do a linear regression model, and then undo that transformation. Anyways, thank you guys so much, and I'll see you in the next lecture.